Discover the two fundamental ways of releasing nuclear energy and how they differ from each other. Nuclear reactions come in two forms: fusion, where small nuclei combine, and fission, where large nuclei split apart. Let's start by understanding nuclear fission, the process that powers today's nuclear reactors. Nuclear fission is the process of splitting a heavy atomic nucleus into two or more lighter nuclei. A neutron strikes a uranium-235 nucleus, which is a large and unstable atom. The nucleus splits into two smaller fragments, releasing additional neutrons and enormous amounts of energy in the process. A typical fission equation shows uranium-235 plus 1 neutron producing barium, krypton, 3 neutrons, and releasing energy. Now let's explore nuclear fusion, the process that powers the sun. Nuclear fusion is the opposite process, where two light atomic nuclei combine to form a heavier nucleus. Two hydrogen nuclei, which are the simplest and lightest atoms, approach each other at extremely high speeds. They fuse together to form helium, releasing tremendous amounts of energy in all directions. The fusion equation shows deuterium plus tritium, two hydrogen isotopes, producing helium, a neutron, and releasing massive energy. Let's compare the fundamental differences between these two nuclear processes. The first major difference is the size of nuclei involved in each process. Fission uses large, heavy nuclei like uranium, while fusion uses small, light nuclei like hydrogen. The second key difference is the conditions needed to trigger each reaction. Fission can occur at room temperature when a neutron strikes the nucleus, but fusion requires temperatures of millions of degrees to overcome the repulsion between positively charged nuclei. Both processes release enormous energy, but there are important differences in how much. Fusion produces more energy per reaction than fission when comparing mass to energy conversion. Einstein's famous equation E equals mc² governs both processes, converting mass into energy. Let's look at how we use these processes today. Fission has several practical applications already in use. Nuclear power plants use fission to generate electricity, providing about 10% of the world's electricity. Fusion powers the sun but is still experimental on Earth. The sun uses fusion to create energy, but we haven't yet achieved sustained fusion power on Earth for practical energy generation. Each process has unique advantages and challenges. Fission technology exists and works, but creates radioactive waste that must be stored for thousands of years and carries radiation risks. Fusion promises clean energy with abundant fuel from water, but we haven't achieved practical fusion power plants yet due to extreme technical challenges. Let's summarize the key differences between fusion and fission. Fission splits large nuclei apart, while fusion combines small nuclei together. Both processes release enormous amounts of energy by converting small amounts of mass into energy. Fission technology works today in nuclear power plants, while fusion remains a promising future energy source. Understanding both processes helps us appreciate current nuclear technology and the exciting possibilities for clean energy in our future.